Okay, so in this video, I'm going to talk about deductive reasoning. And deductive reasoning, from this definition, deductive reasoning uses facts, definitions, accepted properties, and the laws of logic to form a logical argument. This is different from inductive reasoning because it uses specific examples and patterns to form a conjecture. So inductive reasoning uses specific examples to form a conjecture. So it's taking limited information and making a conjecture based on a pattern, okay? Deductive reasoning uses facts, definitions, accepted properties to narrow things down, okay? So there are two laws of logic when we use deductive reasoning. One is called the Law of Detachment, and it says, if the hypothesis of a true conditional statement is true, then the conclusion is also true, okay? So if the hypothesis of a true conditional statement is true, then the conclusion has to also be true. Law of syllogism is a little different. It talks about the hypothesis and the conclusion. If the hypothesis of P implies the conclusion Q, and that hypothesis Q concludes conclusion R, and those statements are true, then the original hypothesis and the conclusion from the second statement, that forms a conditional statement that is also true. So I would start with if P then Q, and then if Q then R. If both of those are true, then I connect that to if P then R. So law of detachment basically uses one statement. A true conditional statement is true. If the hypothesis is true, then the conclusion is also true. Syllogism uses two statements, where I form an original if-then statement, and then I use the conclusion of that original statement to form a new if-then statement. If both of those are true, the original hypothesis implies the final conclusion. So, in example 4 here, it says, if two segments have the same length, then they are congruent. You know that BC equals XY. So using this law of detachment, what statement can we make? Well, we have a rule here. Two segments being the same length are congruent. We've talked about that before. So we would say, because BC equals XY satisfies or makes that hypothesis true. Oops. Because it satisfies the hypothesis of a true statement. The conclusion is true as well. And this is going to look a little bit weird, but that conclusion is true. So I could say that BC is congruent to XY, okay? So it's saying if two segments have the same length, then they're congruent. I said these segments have the same length. That means that they're congruent. Next, example 5. If possible, we're going to use a law of syllogism. So that takes two statements to write a new conditional statement. Okay? So the first statement says, if x squared is greater than 25, then x squared is greater than 20. The second statement says, if x is 5, then x squared is greater than 25. So if we look at this, we notice the conclusion of the second statement, x squared is greater than 25, is the hypothesis of the first. So with law of syllogism, we're looking for if the conclusion of one statement is the hypothesis of the other, we can write a new statement. So the new statement I would write is, if x is greater than 5, then x squared is greater than 20. So we can imply that based on the conclusion of one statement being the hypothesis of the other. That's all the law of syllogism is telling us. If the conclusion of one statement is the hypothesis of the other, we can write those two statements as one, okay? In part B, it says if a polygon is regular, then all the angles of the interior of the polygon are congruent. The next statement says if a polygon is regular, then all of its sides are congruent. So we do have the statement a polygon is regular. Sure, that does match up, but this is the hypothesis of one is the hypothesis of the other. So we would say neither statement's conclusion is the hypothesis of the other. So we can't make any sort of statement from this using the law of syllogism. Okay, so when we look at that, we just say, if the conclusion of one is not the hypothesis of the other, we cannot use the law of syllogism to write a new statement. Okay? So in example 6, it asks, what conclusion can you make about the product of an even integer and any other integer? So in this case, we are going to have to use kind of inductive and deductive reasoning at the same time. And if we think about it, when I multiply something by an even number, it should make sense that that result is going to be even. Okay? So what I really just want to do is show that result will always be, sorry, I'll write that better. That result will always be even. Okay, so when we talk about this, if we think about it, any integer I write that is even can be written as 2 times a number, right? Because any number multiplied by 2 is even. That's the definition of even. So basically, if you think about it, if I introduce another number to multiply it by my original number, it's 2 times 2 other numbers. I'm still multiplying by 2. So it's still going to be even. So that's the way we can say the product of any even number and any other integer is also even. Okay? So moving ahead to example 7. In example 7, we have to decide whether inductive or deductive reasoning is used to reach these conclusions and then explain. So the first one, part A, each time Monica kicks a ball up in the air, it returns to the ground. So the next time she kicks a ball up in the air, it will return to the ground. That is a classic example of inductive reasoning. She is using, or we are using, patterns to draw a conclusion. Okay, using patterns to draw a conclusion is inductive reasoning. In part B, all reptiles are cold-blooded, parrots are not cold-blooded, Sue's pet parrot is not a reptile. A little bit of a goofy statement, but that is another example. That is an example of deductive reasoning. And the reason that's deductive reasoning, we're using facts about animals and laws of logic. So this uses facts and logic to reach our conclusion, right? So basically you're looking at these two statements. All reptiles are cold-blooded. Her parrot is not cold-blooded. Well, then her parrot can't be a reptile because it's not cold-blooded. That's logic. That's a fact. So we're using deductive reasoning there. So in the guided practice, use those same tools 8 is using the law of detachment, 9 is using the law of syllogism, and then deductive or inductive reasoning. So I will work through these, and then I'll have you come back and check your work with me. Okay, so to finish this off, I'm going to run through the guided practice. In part 8, it says if angle R is between 90 and 180 for degree measure, then R is obtuse. So if R is between 90 and 180, R is obtuse. And then I give you a specific example. R is 155. So using the law of detachment, the measure of R satisfies being between 90 and 180, so the conclusion I can make is R is obtuse. So it's just using that first statement and then using the second statement to draw a conclusion. And number 9, using the law of syllogism. We're looking at the conclusion of one statement is the hypothesis of the other. So that means I can write the hypothesis. You get an A on your math test with the conclusion, then you can watch your favorite actor. So it's using two statements to write a single statement. But the conclusion has to be the same as the hypothesis of the other statement. Next, using inductive reasoning to make a conjecture. If I add together two numbers, and those numbers are identical, deductive reasoning tells me the sum of a number in itself is the same as 2 times that number, right? 5 plus 5 is 10. 5 times 2 is 10. So an example of deductive reasoning to use that is a general case here. Using what we know about combining like terms, it doesn't matter what the number is. A number plus itself is 2 times that number. And then 11, deciding whether inductive or deductive reasoning is used. Well, we look at this situation. It says all multiples of 8 are divisible by 4. 64 is a multiple of 8, so 64 is divisible by 4. That directly connects to number 8 here. We've got a statement that is true in a specific case that satisfies that statement, so we can draw that conclusion, that 64 is divisible by 4. It fits that law of detachment. So we're using facts, we're using logic to draw a conclusion, not patterns. So now you can move on to the practice. I think that the practice will be a good way for you to kind of analyze these statements. What I really care more, the difference between inductive and deductive reasoning, and that you can draw some conclusions, okay? Law of detachment, law of syllogism, being able to pick that out, we will get better at. But the main thing is know the difference between inductive and deductive reasoning and how to use them.